Hello, Keith Rucker here at VintageMachinery.org. Guys, so today we are back to working over here on the connecting rod bearings for the Vulcan Iron Works steam locomotive out at the Georgia Museum of Agriculture. And we have already been working on, we've already made some new bearings to go on the front and the back. These will connect to the pins that come out on the wheels, the front and rear wheel on the locomotive, and this is the connecting rod that connects the two of them. I've already got them installed. Right now we're getting the whole rod set up and ready to reinstall back on the locomotive. But before I do, I wanted to make new pins, two new bolts to go in here to connect all these together. These bolts that are in here are quite worn. They've been banged on and beat on for years and years and years, possibly original to the locomotive, over 100 years old. Don't know that for a fact, but I do know that they need to be replaced. So one of the things that we just did previously is I went ahead and reamed out at least this back hole on this one here. We need to still do the front one, but I'm going to get the pin in this one first. And these bolts are a little bit special in the fact that they are tapered bolts. The shaft to here that's solid, that's not threaded, is tapered. On this side, it is tapered at 1/8 inch per foot. So for every foot in length, the diameter tapers down or shrinks in diameter by 1/8 of an inch. So we need to make new pins, new bolts to go in here to match the freshly reamed out. One of the things that I did is I took a tapered reamer, a 1/8 inch per foot tapered reamer, reamed the hole out to get it lined up back together, because again, it was a little bit of misalignment, a little bit of just gunk and stuff down in there, years and years of misalignment, whatever. I want to get these things perfectly aligned so they fit together just right. And to do that, we're going to be making new pins. Now, I've already taken the blueprints that we've got for this, and it shows the bolts on there. And I kind of just made a little chicken scratch drawing of the actual bolt we need to make based off of the information that's on the bigger drawing here. It really doesn't show the bolt in great detail, but it gives me the information I need to be able to make it, plus confirming it with the measurements that we know that we're working with, particularly since I've reamed this out. And it is a little bit oversized from what it was originally because we got it all freshed out now. So we're going to be making a bolt to match the hole. So let me zoom you in here. I'll show you what we got, and we're going to head over to the lathe and start knocking these things out. So just a chicken scratch drawing. This is not to scale, but it gives me the information I need to know. We're going to be making these out of 1 1/4 inch hex stock. This section here is the section will be tapered at 1/8 inch per foot, which comes out to 10.4 thousandths per inch is what that will do. We'll need that when we start setting up the taper attachment. I know that the large diameter needs to be about 0.762 inches in diameter. So probably what we'll do is we'll just turn these out square to that large diameter, and then we'll come back and cut the taper after we've cut everything else. This is going to be 5/8 inch 11 threaded down here, about 1.5 inches long. And then there's just about 1/4 of an inch that sticks out the end. That's way bigger drawn than what it is, but I know the measurements to work with. So I've got all my measurements that I need. We're going to get over here and start turning some of these things out on the lathe. I'm over at my Monarch 16-inch lathe, and we're going to be doing most of our work over here on this. So I've got a couple of blanks cut out. This is 1.25 inch stock, 7.25 inches long. We're going to start on the head end, and I'm going to go ahead and get the top just faced off and get a little profile put around the outside of that to make it a little bit nicer to handle. So let's fire the lathe up. So we'll just come in here again, and we're going to face this off. Get a nice machine surface on there. I'm then going to change cutters. I'm just putting a threading cutter on here because I want that angle, that 60-degree angle. I'm just going to feed in, and I just want to relieve a little bit around that outside edge of that until I kind of knock all the corners down to where you just kind of got a circle all the way around. Need to go in just a tad bit more. That ought to do it right there. And that gives me a nice finish on the top of the head of that bolt. I'm going to go ahead and do the other one while I got it set up to do this, and then we'll flip it around and start working on the other end. good. So now we're going to flip it around to the other end. I'm going to go ahead and put this end in. We're going to face it, and this end needs a center hole in it. All right, we got our facing done. And we'll bring our tailstock in here with a center drill set up, and we'll just go ahead and put a center in there. That's going to give us some support for when we're turning the bolt into this. Now we're going to bring our part out. I'm just going to grip it on the end where the head will be. I want to grip that with as much as I can grip it. That head's going to stick out about 3/4 of an inch, so that gives me a little bit of clearance room there. We'll go ahead and put a center in here to get it lined up nice and straight, and then we'll tighten this down real good. And go ahead and get that center in there tight and lock it in place. All right, I think we're ready to start turning. First thing I'm going to do is I'm going to come in here and kind of touch off on the end. That's going to be my reference point that I'm going to be measuring off of. So I'm going to zero that out on the digital readout. And that way I can kind of tell how far I'm turning from the end. And my first pass needs to go 6.5 inches deep, which is going to bring us right up here to the head. So I'll just dial in 6.5 inches on the digital readout right here. And I'm just going to make a little mark. That just gives me a visual clue of where I'm turning to. And we've got to turn this diameter down to, what is it, 0.762 inches. So just a little over 3/4 of an inch. So we'll just touch off. Start turning this out. Coming up on our mark right there. Make about another 100,000ths cut here. This one's cutting a lot nicer because it's not an interrupted cut. Because we were cutting on that hex on the first pass there, it was kind of heavier cut, light cut because of the difference in the diameter. It wasn't round. Now that it's round, it's cutting much nicer. I don't know, that insert just doesn't act like it's cutting just right. I'm going to put a fresh insert in there, so give me just a second to change that out. See if I can. I got a nice finish, but I don't know, the chips just don't look right. I think it needs a fresh insert. All right, we do have a fresh insert. Let's see how that one looks. Much better. I like that chip. The other one just looked like it was tearing it a little bit. You can tell this is cutting. And that chip's coming off cooler, I can tell just by looking at the color of them as well. So I think that was an improvement. Just want to get a diameter on this, see where we're at. It's about 172. Got the same there. Put that in my digital readout point, or excuse me, 1.072. Just kind of help me see where I'm at. Make sure I don't go too far. We'll make another 100,000ths cut down through there. again, we're going down to 0.762. We should be at about 0.970 right now. And down here on the bottom of the shoulder of my bolt, I'm going to go into that 6.5 inch measurement. We're going to pull out, make that nice and flat. And then I'm going to actually go in just a little bit more. And I just want to relieve around until I got a circle all the way around right there. And that just gets those corners up so that they're not digging in as we go. That should be to size. We're going to come back and cut a taper on that, so even if it is a little bit off, it's not going to matter right now. But yeah, we're actually right on the money. So next, though, what we need to do is we need to come in, what is that, 1.75 inches from the end. So I'm just going to touch off again, make sure my zero is still good, and it is. I'm going to come up 1.75 inches. I'm just, again, using the digital readout to measure this with. 1.750 is what we're going for here. 1.7 right there. I'm going to make myself another little spot to turn to. That needs to be turned down to 5/8. 5/8 is 0.625. So here we go. We'll do it in 2 passes. This is about 100,000ths cut right here. Let's dial it in right off the digital readout. 0.625, which is right about there. Just turn in my hand up to that 1.75 mark. .625, perfect. All right, now I need a little bit off the end here, so this is going to go in 1/4 inch, 0.250 right here, and I want to turn that down to 1/2 inch. Reading it off the digital readout. This measurement is not critical at all, so just getting it close. There we go. All right, so up next, I need a single point thread, 5/8 11 over that area right there. All right, we're going to set up here. First thing I'm going to do is just using that threading cutter, I'm just going to relieve that edge there just a little bit. Give me a nice edge on it. Same thing here. This will be my lead-in angle for the threading, and then also I just want to kind of break that corner down here on the bottom. There we go. Got my zeros set. I'm going to touch off on here, right there. And we'll start by making a little scratch pass. Make sure our pitch angle is correct, thread pitch. I'm going to go grab a pitch gauge and we'll check that. And we got 11 threads per inch is what we're going for here, right on the money. So let's cut some threads. Go back to my zero. Put a little cutting oil on here. We'll wait for a number to come around. Make our first pass. Dial in about 10 more thousandths. Make our second pass. Rinse and repeat until we get our threads cut. Getting close. When I'm threading like this, I'm going to look until I start to get just a little sharp edge on the top of that thread, and that tells me that I'm close to my final size, which I'm close to it right now. I'm going to make one more pass, then we'll do a test fit and go from there. All right, let me go grab a nut, and we will slide it up on there and test it out. A little bit tight still. All right, we'll make another pass. Hit the top of that with a little bit of emery. Sometimes you get a little burr on the top edge of those threads from the threading. This will knock it down just a little bit. And there we go. Nice fit all the way down. Just what we wanted. So up next, what we need to do is get the taper attachment set up over here on the lathe so that we can cut that taper for this pin. And that taper, again, is 1/8 inch per foot. And I'm going to show you how I'm going to set this up using the digital readout and the taper attachment to get it set. And then we'll come in here and make a couple of light passes before we get to the final measurement and actually use a taper micrometer to double check and make sure we are exactly where we need to be. Let's get in here and put this lathe in taper mode and start getting it set up. So to cut tapers on a lathe, at least the way I'm going to do it here is I'm going to be using the taper attachment. Now the taper attachment is not an option that's on every lathe, but if you got one, this is exactly what it's designed to use for, is for cutting tapers like we're going to be doing right here. Now normally in a lathe, when it's set up, when your carriage moves back and forth, the cutter is going to move parallel to the ways in the bed. When we are cutting a taper, we've got this bar back here in the back that can be tilted to whatever angle you want within the range that it can cut, either positive or negative. And instead of following the ways, the cutter is going to follow the direction of this taper. And the way you do that is you're basically I'm going to tighten up this nut right here, this bolt rather. And when I do, what will happen is I can no longer move my lathe in and out, the cross slide in and out using the handle. Is going to be firmly attached, and it's going to be basically connected back here to this here, so that whenever we're moving, this bar is going to stay stationary. I'm going to clamp it down as well, and it's going to just follow it right along. In fact, let me go ahead and get it clamped down. So now what's happening, if you look, when I move the saddle, this bar is going to stay stationary, and there's a little slide that slides over that. It's going to be directly connected to the cross slide. So instead of the handle moving the cross slide in and out, handle won't move now. It's going to move as this slide moves down that angle. So as I move it down, it's coming towards me. As I go back out, it's moving back in. And now what I have to do is I have to adjust my in and out using the compound to adjust my cutter in and out. And normally you would turn this over to 90 degrees so you can measure it. I'm not going to worry about it that much. We'll just kind of play it by ear there. So now that I've got the taper attachment engaged, we need to adjust this bar back here so that it is at the taper that we want to cut, which again is 1/8 inch per foot. So I don't even remember what the last job I had this taper attachment set up on. So what I'm going to do is we're just going to kind of come in here and see where it's at. And to do that, I'm going to use the digital readout. So let me show you how we're going to do that. So my digital readout up here is going to give me some measurements as far as what's actually going on the lathe. And I've got my digital readout set up where it's giving me two different measurements, an X and a Z in this case. So the Z is the table moving in and out. So it's the travel going up and down the lathe. The X is the travel coming in and out. Now normally you would control that travel coming in and out by turning the knob down here on the front, and so we're turning a diameter or whatever, we can keep track of everything that's going on. However, and what we're doing here, because we've got the taper attachment attached in there, it's still measuring that movement as it happens, but now it's measuring it based off of what's going on back here instead of me turning the handle. So I'm going to kind of take the backlash out of this. I'm going to zero out both of them, and I'm just going to move it 6 inches, and we're going to see how far the head moves in relationship, and that will kind of tell us what our taper is. So let's just go ahead, we'll dial that in. I'm just going to dial in, let's do 4 inches. I don't think I got room for 6 inches. So a little over 4 inches, but we moved 415 thousandths is how much the cutter moved away from me. And actually it's going to be half of that because I got it set up on diameter mode, because on lathe you're cutting on one side but your work is turning, so it's also turning on the other side. So the actual amount that it moved was to be half of that, but still on a taper, we're doing a compound taper, so it's going to be 415 thousandths. So we moved 415 thousandths over 4 inches. Let's calculate and see what that is. 0.415 over 4 inches. 4 inches is 1/3 of a foot, so we'll multiply that times 3. So that's 1.25 inches per foot is what we were actually had it set up on previously. So previously this was on an 1.25 inches per foot taper. We want to be on a 1/8 inch per foot taper, so much less than that. I got it over there. I think it's going to be 10 thousandths per inch. So over 4 inches, it'd be 40 thousandths. What was it? 10 4/10. We'll do the math. We'll figure it out exactly. And we'll come over here and start making adjustments to our taper bar until we get it just right. All right, so we need to adjust this bar in the back until we get it set where it needs to be. It needs to be a lot, almost flat compared to what it is now. So there's 2 little nuts that tighten this up, one there and one up on the front, and then this nut on the top allows us to kind of rotate this around. And I'm just going to kind of pick a place, and we're going to tighten it back down, and we'll go back around to the front and check it out. There is a scale on here, but this scale is not very accurate. I've just basically resorted to trial and error to get this thing set up. It's about the best way I know to do it. Let's see where our measurements are, and we'll just keep adjusting until we get it where it needs to be. So we'll come back over here and do this test again. I'll come out all the way to the end, take the backlash out of it. I'm going to zero both my axes on the digital readout. We're going to move 4 inches again. 2, 3. Go slow on that last one so I don't go past it. Right there. Well, okay, 4 inches, and we moved 0.166 inches is how far we moved it. Now for that 1/8 inch per foot taper, I need to be at 0.416, so 41.6 thousandths. We're still quite a bit too far out, so I need to go make another adjustment. And again, this is just trial and error until we get it where it needs to be. I wish there was a more precise way of moving that thing each time, but we're just gonna make do. I've done this many times, it's just trial and error. I'll bring you guys back once I get it set up to the right place, and then we're ready to start cutting our taper. All right, I'm gonna zero this out. I've done this a bunch of times and we're like so close, I don't think it's gonna matter. So let's go 4 inches, 2, 3, 0.0408, and I'm shooting for 0.0416. I'm within 1,000th right now of where I need to be. And honestly, guys, I've done this about 10 times, and every time the number's a little bit off. You can't get it within 1,000th anyway, so some of them are actually better than this. That's about as bad as I'm getting, so it's good enough. It's close enough. 1,000th over 4 inches, I can deal with that all day long, every day. So I think we're just gonna go ahead and start turning this out. So what I'm gonna do now is I'm gonna turn it a couple of passes until I get a little bit of meat coming off of this, and then I'm gonna get my taper micrometer, and we're gonna verify and see exactly where it's actually cutting. That's gonna be the real ultimate test, is how it's actually cutting more so than how it's measuring on the digital readout. DRO will get us close, and usually close enough, but I like to verify. All right, let's fire up the lathe and get to cutting. So I need to come in here and kind of touch off. We're just going to take a light pass here to start with. It's going to start cutting, but as it moves out, you'll see it's going to start feeding out, feathering out, until it quits cutting altogether. An 1/8 inch per foot is not much of a taper, so it'll take a little while for it to come on out. I believe we're completely out now. So we're going to stop. What I like to do is read off my dial where I finished at and back off, come out, come back in, and then take my dial back to where I was at. But before I do, I'm going to get that taper micrometer, and we're going to measure that taper and see where we're at. All right, we'll come in here. I guess this is touching right here and here. This is 1 inch up, and we're going to measure where we're at. And we're measuring 10.6. That's actually excellent, because 10.6 thousandths, 0.0106, 0.0104 is my perfect measurement. So we're actually right on the money. I'm going to just basically turn this a couple of times until we get it feathered out all the way up to the end. We're just going to take some light passes. Just 3 or 4 thou, and we'll let it come back up again. Just taking an ever so slight cut. All right. We're on 72. But I think what I'm going to do now is I'm going to actually take this out over to the part and fit it in there. I think we're going to be pretty darn close right here. I had to take it back and take off just a little bit more, but I think we've got a good fit now. So it goes in, it drops in that far by itself. But remember, this is a tapered pin, and we want to get it, we want to drive it in and tighten it up and get it as tight as we can. So I'm just going to take a hammer, lead hammer here, and just tap it in place. And notice it just sets right in place. That's exactly what we want. a nice tight pin in there that's going to key everything together. So that one is done. Now we need to knock this one out, ream it, and do the same process, make a nut. And these are all going to be custom fit. I'm going to end up numbering these bolts so that they go back into the same place next time we take this thing apart. We'll just number them up on the cap somewhere. All right, I think we are ready to move on. I'm going to get my reamer back out. We're going to ream this hole out and rinse and repeat. We'll make another bolt. And I got my second bolt ready to go in here. We'll drive it home. That is nice and tight. I think we got our pins made. I am going to stamp these and number them so that they always make sure we go back in the same place. So these will get LF on them for left front, and I think it's going to be number 1, number 2, 3, and 4 in the back. Okay, I think we got this side all built out. Got new bearings, new bolts, new reamed out holes holding them together, new shims. So this side is ready to go. Still got to do the other side. I'm waiting to get my tapered reamer for it. I may go ahead and rough out the bolts and get them at least to the rough size, so that all we got to do is go in there and finish turning those once we get the taper in. But we're making progress. Well, guys, I think this is going to be a good stopping point here for this video. We're going to go ahead and just wrap this one up, and coming up next, we're going to get those tapered bolts made and kind of finish this project out. Hopefully get this one back on the locomotive. We've still got another connecting rod still left to do, so I need to get this thing wrapped up. So with that, that's going to be a wrap. Guys, we will catch you on the next video. As always, thank you so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments really helps out a lot, helps with the algorithms over on YouTube, so I'd appreciate that as well. And as always, a big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Enables me to take the time to shoot these videos and bring them to you. And with that, we are going to sign off. We'll catch you on the next video. Again, thanks for watching.